Home. That's where we spend some of the most important moments of our lives, with the most important people in our lives. So, what do we look for in a home? We'd like it to be comfortable, perhaps pretty, like some of the red brick houses that line our Vista's neighborhoods. We'd like it to be affordable, energy efficient. How about safe? Well, here, as in other parts of the country, safe also means resisting extreme events, such as tornadoes and hurricanes, with winds of 150 miles an hour or more. As a matter of fact, we experienced a tornado warning here in downtown Columbia just a couple of days ago. And also earthquakes. In fact, South Carolina sits in the most seismically hazardous area on the East Coast. Now, why do I care about this? I'm a civil engineer and a college professor. I spend much of my time teaching and doing research on construction materials and their structural applications. This passion started quite early because of this. A gorgeous 16th century Palladian bridge made of bricks and stone. It connects two sides of my hometown in Italy, which would be separate otherwise. For me, home and friends on one side, school and sports on the other side. But this passion really took off the first time I laid eyes on a research laboratory, like this one. As I was planning for a year as a visiting undergraduate student in the US, I saw a website with just a few but powerful pictures. And I marveled at the fact that there are some people who actually test their ideas in real scale experiments. And that also put a smile on my face because that was a path to carry on the Lego mania that I've had for as long as I can remember. Now, fast forward a few years, and it's here, in our civil engineering research labs, where together with students and collaborators, we investigate how to make our infrastructure stronger and more durable. We literally break things in the lab so they don't break out there where it counts. Sometimes we use fancier materials, such as the reinforcing bars that are hidden inside the new concrete seawall along Charleston's beautiful Low Battery. They aren't made of conventional steel, which might rust because of the constant exposure to aggressive salt water. Instead, they're made of very lightweight fiberglass that's not going to corrode. Some other times, we use simpler materials. It's important, it's especially important when affordability matters. A case in point is dirt. That's right. It's locally available, fairly cheap, but some might also view it as kind of subpar. And yet, we can turn it into this brick material, which ticks all the boxes. It's pretty, it's energy efficient, it's even good at regulating indoor humidity. But safe? Hazard resistant? Yes, yes. That's when the change makers in my business come out to play. Science and engineering, they turn the very difficult, sometimes the seemingly impossible, into the very possible. For example, turning a building material that's perceived as subpar into a really cool one that's environmentally friendly, good-looking, and exceptionally resistant, even against tornadoes and hurricanes. Now, some of you might be wondering if I'm taking it a little bit too far. You know, engineering professor in his ivory tower with his mind wandering somewhere else other than in the real world. And you wouldn't be entirely wrong, but on this one, hear me out. How do we do it? How do we make this hazard resistant? We start from typical house floor plans, and we use math and physics to figure out how strong the load-bearing walls have to be in different directions, crushing, pulling, and shearing to resist extreme wind pressures. For example, in our case, we calculated we need about 30 tons per square foot in compressive force, which is not too shabby. Then we get to the prototyping, Here we use a little bit of materials engineering, and we make our prototype bricks with a hydraulic press using local soil from Lexington, right here. A little bit of cement, a little bit of water, and different from the red bricks we're familiar with. No furnace, no firing. That way, we also keep it low energy. Next, our students create the prototype masonry by combining earth bricks and earth mortar made with the very same soil. And now comes the time to cross our fingers as we load test our prototype masonry in different directions, compression, tension, shear, to see if it reaches the target strengths we calculated. And in fact, this is when we verify through experiments that the prototype actually works. It can resist extreme pressures from tornado and hurricane winds. So we don't live in an ivory tower, at least most of the times. We can be pretty practical people, but then the researcher side kicks in. Now that it works, how far can we push it? After all, it's fair that we tell ourselves what we tell our students all the time. The sky is the limit. So what's the limit? Well, here, the limit is making our masonry not only green and strong, but so resistant, that it could be used even for safety shelters where people rush to find refuge during a tornado. In fact, that's what we did during the tornado warning just a couple of days ago. We took shelter at the basement of the engineering building. Now, to get there, walls have to be able to resist the impact of flying debris, such as pieces of roof, pieces of walls, studs, and whatnot, picked up by the wind and hurled through the air. To get there, walls have to be able to resist the impact of this flying debris. And FEMA, meaning our Federal Emergency Management Agency, requires a missile test, meaning launching a 15-pound, 2x4-inch wood stud at 100 miles an hour against a candidate wall. So what do? We have no choice. We build a cannon to launch 2x4 studs at 100 miles an hour against our prototype masonry. After all, I did say the sky's the limit. Now, before I get ahead of myself, let's watch together our first attempt in this short video.
3, 2, 1.
Ouch. Ouch. We did take it too far. The stud goes straight to the wall like it's not even there. So we learned that our prototype is good enough for extreme wind pressures, but not for safety shelters. On this, we failed. We had to do better if we wanted to make our masonry good, also for impact, also for potential use in safety shelters. Now, to take on this challenge, we step up our science and engineering game, and to our math and physics and materials engineering and structural analysis and physical testing, we add another tool called fracture mechanics. In practice, we fix, some of us may say we re-engineer, our masonry by introducing some reinforcement with the purpose of holding the cracks together, enough to stop the impacting stud. And just in case any of you were wondering, yes, that is a wall that's standing on its own after cracking, after failure, because the reinforcement is holding it together. What's reinforcement, though? Remember, this is about science and engineering, no fancy stuff. So we cut strips from recycled plastic sheets using, and this is a brilliant idea by a great student, a pasta machine. Right shape and size. Tagliolini, for the records. This plastic comes, for example, from bottles. And it's non-biodegradable, so it's a problem if it piles up in a landfill. However, in my business, Non-biodegradable can also mean durable, which is what we want in a home. So here we are. If there was a time to keep our fingers really crossed, and believe me, we did, that was it. Let's see how it went in this other video.
3, 2, 1.
Second time's a charm. And the stud is stopped by a wall that's just 7 inches thick, thinner than we would normally use for a load-bearing wall. All thanks to local dirt, reinforced with recycled plastic, cut with a pasta machine. This is how much difference science and engineering can make. When my son Andrea was 5, he asked me a couple of questions out of the blue. He said, why are we here? What are we doing here? Here meaning in this world. They caught me by surprise and stuck with me ever since. I didn't have a straight answer, so I told him I had to think about it. And when I got back to him the next day, the answer simply boiled down to, we're here to do something good. It doesn't matter how small. So for myself, as well as many friends and colleagues around the world, this is what inspires our students, from high school interns to doctoral candidates, as they branch out and keep making the difficult, sometimes perhaps the seemingly impossible, happen by studying, understanding, trying harder, succeeding, sometimes failing, but along the way, always learning, and along this way, bettering their lives and the lives of those around them. In other words, using science and engineering to make a difference and do something good. Thank you.